Hello everybody, in today's lesson we're going to be learning how to find extrema that is closest to the origin. So if I give a function f of x equals sine x minus y, and you want to find the extrema that is maxima and minima that is closest to the origin of this function. So how do we solve it? Well, we first of all need to take the derivative, so f prime of x is cosine x minus y, and when you take it respect to x will be 1 minus y prime. So that is the derivative first. So we first take the derivative in respect to x, right? And second, we let y prime be equivalent to 0 because we know that at extrema the tangent line's slope will be 0, since when you have an extrema like let me draw a graph like this, when you're at in the critical point, the tangent line of that critical point will always be 0. That's simply logic. So that's that. So when you set it to be 0, you get these properties. 0 equals cosine of x minus y times 1, which will be cosine x minus y. Now we simply just have to do some algebra to solve this equation. Now, when cosine is 0 is when cosine equals pi over 2. And you could say also it could be negative pi over 2 or 3 pi over 2. But we know that since we're taking it closest to the origin, these numbers are going to be the ones that are closest to the origin. So we have to find x minus y equals pi over 2 and x minus y equals negative pi over 2. So these are the coordinates we need to find. But we also know from our original function sine x minus y. So y equals sine x minus y. Sine x minus y. And we know x minus y equals pi over 2, so it equals sine pi over 2, which is 1. It's lagging really bad, which equals to 1. So when you have y equals to 1 down, you can find out what x is. So coordinate when y is 1, x is pi over 2 plus 1. Right, just algebra. Now, alright, the lagging is gone now. So y equals sine x minus y, which is negative pi over 2, so negative pi over 2. This I should write to be pi over 2. When it's negative pi over 2, it will be negative 1. So the coordinate will be negative 1. And then you plug it in, which will be negative pi over 2 minus 1. And those are your coordinates, but we need to know now whether it's a maxima or minima. Now to know whether it's a maxima or minima, we need to look at what the y values is. So to know whether it's extrema, we could take double prime, right? If you want to do a purely algebraic way, you take double prime, and then after you take double prime, if it's greater than 0, it's a minima, and if it's less than 0, it's a maxima. Okay. But in this case, we also know like a simple hack. You determine whether it's a maxima or minima. You just simply look at the y value. So you just simply look at the y value. For here, since we know that this graph of sine, okay, the lagging is back again, and I can't write. Come on. So for sine, we know that it's gonna be graph like this, something like that. So when y is greater, you know that's gonna be a maxima, and y is less, you know that's gonna be a minima. So for this one, this will be a maxima, and then on the bottom it will be a minima. Okay, so that's simply how you do it. But when we know that for tangent and cotangent, since the graph is something like that, you know that there won't really be a maxima or minima. But when there's secant and cosecant graph something like this, you know that there will be a maximum minima. But the thing is reversed. when the y value is greater, it will be at minima, and when y value is less, it will be at maxima.